And here I'd like to carry on and with a third thing to do with dilutions, and that is how to work out what volumes you need to mix to give your desired concentration. So, for example, let's show you what I mean by just telling you the example I'm going to use to show you. So how would you make 2 milliliters of a 20 cells per milliliter culture, starting from a 500 cells per mil culture. So this is kind of carrying on from what we did before. So the first thing you have to do is work out what is the dilution factor. So you already know how to do that. So this is just the same as we had before, so that's 500 cells per mil. We have to divide by 25 to give us 20 cells per mil. We just worked that out before. And second, we have to work out what volume that corresponds to. So, what volume equals 1/25 of that final volume? Okay, so remember the definition of dilution factor is that it's the total volume over the volume of concentrate. So we know the total volume, we want to know the volume of the concentrated starter solution. So in this case it's 1/25. So we could say this is 1 over the dilution factor. So let's just work through that. So that would be, so we simply divide the volume by 25 in this case. So 2 milliliters divided by 25, so that gives us 0.08 milliliters in this case of concentrated cell culture is required. And then we mix that with water, so we make up to a final volume of 2 milliliters, and we can work out roughly how much that would be, but in real life you wouldn't just add that volume, you would make up and measure that it ended up at exactly 2 milliliters. So in this case the remainder is the diluent, so probably buffer or media, sorry, that's the word I meant to use. So that's 2 mils minus 0.08 mils, which is 1.92 mils. So let's just quickly do another example. So this one isn't using cells, this is using a chemical. So how would you make 10 mils of a 1 milligram per milliliter solution starting from a 50 milligrams per milliliter stock solution? So that's for the word we use in the lab for the concentrated solution. So the first thing you have to do is work out what the dilution factor is. So we're going from 50 milligrams per milliliter to 1 milligram per milliliter, and 50 divided by 1 is 50. So that means here go divided by 50, and then we have to work out how that volume corresponds to the proportion of the final volume that we want. So we'd say 10 milliliters divided by 50, because 1/50th of that 10 millilitres will be the concentrated stock solution, so that's 0.2 millilitres of stock solution would be required. Then you'd make up to 10 millilitres, and it would be roughly 10 mils minus 0.2 mils, which is 9.8 mils of water.